So in this video, we're going to look at solving linear equations where we've got more than one x. So if we look at the first example, we have 3x equals 12. What that means is we've got 3 lots of x, which equal 12. So 3 times a number will give us 12. So what we need to do is work out which number we're multiplying by 3 that would give us 12. So if we're multiplying by 3, we will get 3x, but we only want 1x, because remember, we're going to have our 1x at the bottom. So how am I going to get rid of the 3 that I'm multiplying x by? Well, we need to think about the inverse of times 3, and we know that the inverse of times 3 is divide by 3. So again, we need to make sure we're dividing by 3 on both sides because we need to keep the equations balanced. So that means we get 3x divided by 3 equals 12 divided by 3. And it's really good in questions like this to make sure that we keep the divide as a fraction because it makes it a lot clearer as to what we're doing. So if we look at that, what's 3x divided by 3? We've got 3 times x divided by 3. And if we look at what's common on the top and common on the bottom, we've got a 3 in both. So they cancel each other out because 3 divided by 3 is just 1. So that leaves us with our 1x. And then 12 divided by 3 is 4. So that means that x equals 4. So if we go back to our original equation, 3 times x equals 12. Well, now we know that x is 4. So does 3 times 4 equal 12? Yes, it does. So we've solved that equation. If we go to our next example, we've got 4 lots of x, which equals 17. Now, how am I going to get rid of my 4 lots of x and just end up with 1 lot of x? Well, I'm multiplying x by 4, so I need to do the inverse of that. So I need to divide by 4 this time. And remember, we're doing that to both sides to keep the equation balanced. So we're going to have 4x divided by 4 equals 17. And again, we're going to divide 17 by 4. So if we look at that, we've got 4 lots of x and we're dividing by 4. So 4 divided by 4 will give us our 1. So we end up with just x on that side. Now, it's when we look at 17 divided by 4 that we have a slight problem. We know that 17 divided by 4 isn't going to be a whole number because 4 only goes to 16 or to 20. So what we need to do is leave this fraction like that, but we're going to make it a mixed number because we can't cancel it down to a whole number. So to make it a mixed number, we need to see how many 4s go into 17. Well, that's going to be 4. And what we have left over. We've got 1 left over because 4 into 17, 4 times 4 is 16. And that leaves us 1. And it's 1/4 that we're left with. So that's our final answer. And again, we can check that because we'll put it back into our equation. 4 times the 4 would give us 16, and then 4 times the quarter would give us an extra 1, and 16 plus 1 is going to give us our 17. So that's correct. Now, if we move over to this side, you can see that my equations have got slightly more complicated because not only am I multiplying x by something, but then I'm adding something on to the end, and then I'm getting my answer. So in the first one, I've got 3 times x, and then I'm adding 4. So what I need to do is I need to work out a way of getting rid of the times 3 and the plus 4. Now, the first thing I'm doing to x in this equation is multiplying it by 3. And it's the 3x as a whole that we're adding 4 to. So that plus 4 is the first thing I need to get rid of. How can I get rid of plus 4? Well, I'm going to make it 0, so I'm going to take away 4. So I'm going to do that to both sides. So I get 3x plus 4 minus 4 equals 19 minus 4. If we look again, we've got the plus 4 and the minus 4, which is going to give me 0. So I'm just going to have 3x plus 0 on this side, so I'll leave it as 3x. And then here, I've got 19 minus 4, which is 15. Now, I'm not finished, because remember, I want my equation, my solution, to just be x equals something. And currently, I've got 3x equals 15. So I need to get rid of that 3x. Now, as we did over there, we were multiplying by 3, so we're going to divide by 3. So divide both sides by 3. And that's going to give me 3x divided by 3 equals 15 divided by 3. So we know that 3 lots of x divided by 3 is going to cancel out just to give me 1x. And 15 divided by 3 is going to be 5. So my solution is x equals 5. Now, if I put that back into my original equation, I've got 3 times 5, which is 15, plus 4, which gives me my 19. So again, that one's correct. Now, finally, if I look at my last equation, 5x minus 2 equals 1, I'm doing x times 5, and then I'm taking away 2. So I'm taking away 2 from my 5x as a whole. So that means I need to get rid of this take away 2 first. How can I get rid of minus 2? Well, I'm going to add 2 to both sides, because that will give me the 0 on this side that I'm looking for. So I end up with 5x minus 2 plus 2 equals 1 plus 2. Now, if I look at it, my minus 2 plus 2 gives me the 0 I wanted, which is perfect. So I've got 5x equals 3. So now I'm doing my 5 times x, which gives me 3. So how am I going to get rid of my 5 times? Well, I'm going to divide by 5, because that's the inverse of times. So again, do that to both sides. So I've got 5x divided by 5 equals 3 divided by 5. Remember, I'm dividing both sides by 5, which is why I've got my fraction of divide by 5 there. So 5 divided by 5 is just going to give me the 1. So I'm left with 1x, which is what I want. And then 3 divided by 5. We can see here that, again, we're not going to get a whole number, just as we had in this example. So what we need to do is either leave it as 3 over 5, or if we wanted to, we could change it as a decimal. I would always leave it as my fraction 3 over 5, because that is the fraction in its simplest form, and I can't cancel that down any further. So that's my solution. Again, if I put that into my first equation, I could check it. Now, one last thing I want you to notice. In all of my examples, I have the equal signs lined up. That's a really important thing to do, especially in exams when you're doing this type of question. Lining up our equals makes it clear and makes it obvious to the examiner exactly what we're trying to do. And it also makes it clear to you, or to me, whoever's writing it, and you can follow it in a really structured fashion, rather than just having it all dotted all over the place.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah, absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.